Hello. For this lesson, we're going to be graphing functions, and there are some basic or common functions that we graph. As you see here, we have a line, which is just f of x equals x. Remember that the same thing could be y equals x. The second one, this is a parabola, f of x equals x squared. So if it has an x squared, we call that a quadratic equation. It always graphs as a parabola. And then we have the absolute value function, and this function graphs as a v, right? So notice we have a v. And then we also have the square root function, and it graphs with a starting place, right? Notice it doesn't have arrows going in two directions, just the one way, because we can only use positive numbers because the results have to be real numbers. So that means 0, 1, 2, 3, those are the only numbers that we can substitute in for this graph. Now these are sometimes called parent graphs. Common graphs is a good way to go to, and we're going to be using transformations. So we're going to take the basic graph, the common graph, and we're going to shift it up, down, left, right, or reflected over the x-axis. So those are called transformations, and that's how I'm going to teach this, is just using those the shifting and actually naming what am I doing here with this graph. And so we're going to start out with just an absolute value function. An absolute value function, remember, this makes a v. It has to make a v. You can't take a function that's supposed to graph as a v and make it into something else. Okay. Now we're going to use the table, the xy chart, with the common function. So we're going to use f of x equals the absolute value of x. Now what we're going to do is use the basic or common graph in order to get the graph we're supposed to be graphing, g of x equals the absolute value of x minus 2. Now I want you to notice up here I have this little chart, and it tells us what happens when we have a number out here, right? What is that telling us to do? Well, this is telling us that our common, we're going to go from a common graph to a shift, and it's going to be downward 2. And so notice when it says minus k, f of x minus k, then we're going to shift downward. So for the original chart, it's really quick, and it turns out the same every time. I did have it labeled over here, so you can see we're at 1, 1, and 2, 2, and negative 1, 1, and negative 2, 2. That's the case every time. So on this, we're going to be at 1, 0, and 1, because remember, I'm just taking the absolute value of the x coordinate. The absolute value for the first one is 1, and then 0, and then 1 again. So when we put this graph on the coordinate plane, we're going to use pink and dashed lines. So all of the pink dashed lined graphs are going to be our parent graph. I'm going to put a point here and here and here. Now you can do more points in this, but it's not really necessary. And then we just are going to dash our two sides of our V. I'll try to hit this decently. And then of course arrows. Sometimes students don't put arrows because when they're graphing on MyLab, it doesn't put the arrows. Okay. Now for the second graph, notice the dotted graph is to help us graph what we're supposed to be graphing. And this is where the transformation comes in. We're going to shift down, right? This means shift down 2, or downward. I'm just going to write down shift down 2. Now that simply means that the points on the graph for our basic graph are going to move down 2. And we don't have to make a chart or anything. We can just count on the graph, and this is really the easiest way to do this. And once you get it down, oh, this basic graph is going to graph this way every time, then that makes it pretty simple. Okay, so if we shift each of the points we put on here, we put 3 points. I'm going to take this first one, which is at the vertex, and count down 1, 2, down 1, 2, and down 1, 2, and then draw our lines. Yeah, my line's not looking too straight. It's just going to have to be. When I draw on my surface, sometimes I have a hard time with straight lines. Okay. Kind of worked out better going from that direction somehow. Okay, so the blue graph is the graph, right, of g of x equals the absolute value. Let me take that off of there and try that again. So we have a shift down 2. The blue graph is the g of x equals the absolute value of x minus 2. Okay, so let's look at the next one. We're still shifting up or down with this. I have the same chart, right? It's called a vertical shift. And it's a vertical shift when we have that extra number out there. Now, this is a square root function. So on the square root function, we pick certain points for square roots because we can't use negative numbers, because if I use a negative number, that's not a real number, right, that I get as a result of that. Oops. Oh, it's doing that weird thing. Okay. So we need to choose positive numbers for x, and we actually get pretty specific with this. Hold on, I actually wanted to use pink here. All right, so I'm going to use 0, 1, 4, and 9. Now, a lot of times students are like, where do those numbers come from? Well, those are called perfect squares, right? I can take the square root of each one of those and I get a nice whole number. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. I went ahead and put the 9 on here just so we would have a little bit more on our graph. Now we're graphing this with the dotted, right? We're going to use a dotted, it's not really a line because it has a curve. And so we're going to put a point at 0, 0, 1, 1, 4, 2, 9, 3, and then we're going to connect with a dotted line, sort of curve, and that's it. Now we're going to use this to graph the g of x function, which is the square root of x plus 3. Certainly you could make charts with these and everything, but it's just not necessary, and usually much more confusing if you do try to do that. Okay, so here's what happens. This 3 is telling me this is going to shift upward or up 3. That's it. All we have to do is count on our graph. So from our common graph, right, the original common graph, we're going to just shift all the points up 3. So we count 1, 2, 3, 1, 2, 3, 1, 2, 3. Maybe try to hit that a little better. 1, 2, 3, and then we connect that with a nice smooth curve here, hopefully, somewhat. And that's it. That's the blue graph is g of x equals the square root of x plus 3. Okay, moving on. So next we have a quadratic function. Notice it has an x squared, and we have a little bit different chart. This is a horizontal shift. Now sometimes the horizontal shifts are a little bit more confusing because for these you have to use the opposite sign of what's in the parentheses. So when it's a plus, we write a plus when it's minus a negative number, and this is where this comes from. So our g of x function, let me go back to my blue, our g of x function is telling us that we're going to shift left 4, right? Because we have to look at that as the 4 originally was negative, so it's going to shift to the left. Now we are still making our original here from our common graph. I'm using -1, 0, and 1 for this. So -1 squared is 1, and 0 squared is 0. 1 squared is 1. Now when you graph this, you want to try your best to make it curved so it doesn't look like the absolute value function, because you'll notice that we're actually graphing the same points. You could go ahead and do -2, because -2 squared is 4, and 2 squared is also 4, if that helps you a little bit on this. So at 2 we would be at 4, and at -2 we would be at 4. So if that helps you to put a few more points on the graph, you certainly can on your parent graph, so it helps you with the shifting. Okay, so we want to curve this so we do our best to make it look like it's curving here. I'm going to try that. And then same thing on the other side. Put another little line through there, another dash. And we have a parabola. Now, to graph the function that we're supposed to be graphing, which is the g of x, this is how I want you to graph these. I want to see the parent graph or the original graph. If you were taking a test for me, that's what I need to see. And then I would have to see the new graph, right? The one you're supposed to be graphing, which is the function g of x equals x plus 4 quantity squared. It's shifting left 4. So let's just count. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4 on that one. Let's go ahead and do these. 1, 2, 3, 4. And then on this one, 1, 2, 3, 4. Notice we're going to go right through there. And that's okay, right? That's just perfectly fine. All right, so there's one side of my parabola. And here's the other. And then we have a graph. Your graphs don't have to be perfect. They just have to be decent, okay? And so you can see that we have a curve there at the bottom, which we want. And then we have our parabola graphed. Okay, so I'm going to stop this video and pick up the lesson on the next video.